So, for lab chapter 1, we used two charged pieces of tapes to help us understand the types of charges, how the charges react to each other, and we were also able to calculate different things such as the amount of charge on the charged piece of tape. For starters, the lab was divided into not two separate parts, but multiple small subsections. And for the first experiment, we charged two separate pieces of tapes to see how they will react to each other. So my initial assumption is that because we charge the tapes the same exact way, that they will have the same charge. And because they have the same charge, I assume that they will repel each other. This ended up being true, and we later found out that the tapes are positively charged based off the fact that it was attracted to a negatively charged pin. So in one of the subsections, we negatively charged a pin because we know that opposite charges attract each other. So when we negatively charge this pin, if it was attracted to the charged tape, then the tape would end up being positive. But if it repelled, we can assume that the tape was negative. In the next experiment, we charged two separate pieces of tape once again, suspended one in the air, and used another one to place underneath and get that top tape to float. There was a few assumptions that we can get off of this. One of them was that because the tape was floating and the momentum has ceased, that the gravitational force and the electrical force are equal to each other. We can assume this because that tape is not moving in the y direction anymore. It's not moving up, it's not moving down, it's floating. So we know that gravitational force is a downward force. We know that electrical force is going to be repelling that tape, forcing it up, so that they have to be equal and opposite of each other. Because when we make this assumption, we can then calculate the charge on the tapes. Another assumption that we made was that the tapes were evenly charged, and that because it's evenly charged, we can choose a point charge to represent the tapes, which will make it easier for us to calculate the charge. So using algebra, we were able to get that in this case, I named the charge QB. So QB equals the square root of mass times gravitational acceleration times the distance between the two charges squared over k, which is a constant. Once we did that, I came out with the answer 5.974 newtons coulombs, which is also 5.974 times 10 to the negative 9 coulombs. After that, I was able to calculate the amount of charge on the tape by calculating surface area of the tape, which was the width times the length, the area of the atoms, and dividing the surface area by the area of atoms and getting 3.87 times 10 to the negative 17. Then taking that number and dividing the number of electrons by the number of atoms on the surface, which I got was 9.649 times 10 to the negative 8. And this was all because we assumed that the net charge was distributed uniformly. So I said it earlier, because we assumed that it was distributed uniformly, we were able to use 2-point charges or 1-point charge per tape, making it easier for us to do this. So additional questions asked for this lab was, what if the electrons had positive charge and the protons had negative charge? What would change the observations you made with your tapes and other charged objects? I believe that if the electrons have positive charge and the protons have negative charge, the assumptions that we have and the answers that we have wouldn't change, because ultimately, um, so we know that both of the tapes were positively charged. So if all of a sudden that those tapes were negatively charged, then it would still have the same effect on each other, because they're both still they both still have the same charges. So each will act in the same way. Second question is, why is it important to handle the charged tapes as little as possible? And what happens when a charged tapes come in contact with your hands or other objects? So it's important that we didn't touch the tapes, that we touch the charge as little as possible, because the more that we touched it, the more neutral that the tape became. This is because our bodies are great conductors, and we have a neutral charge within us. So when we touch that tape, the electrons and the protons balance out between both us and that tape. So we try to touch it on the ends as much as possible.